On the interval from 0 to 2 pi, determine which angles are not in the domain of the tangent function and what angles are not in the domain of the tangent function on the given interval. So for this one, there's two ways that you can approach this. Since we were really creating and describing graphs in this section, I want to show you a picture of a graph first and talk about how from the graphs that we learned, we can figure this out. So first, just kind of review, if we are looking for things that are not in the domain, and it says angles not in the domain, and it says that because we're doing tangent of theta, and theta is our angle. So first, let's go ahead and restrict our picture between 0 and 2 pi. So we're looking at the graph between 0 and 2 pi. And basically, if you go back to your functions, domain is your x value. So for us, that's our theta. So this is theta. You want to think, what values are not going to be in there? So graphically, we can see that the values where we're creating these vertical asymptotes are the values that are not going to be in there. And we can see that those values are at, if this is pi, then those values are going to be at pi over 2 and 3 pi over 2. And again, this goes back to what we learned in how this is graphed. We learned in the lecture that our graph cycles between, we would get one graph here, you can see between negative pi over 2 and pi over 2, and then it just cycles through every pi. And so it has shifted it over to us looking at 0 to 2 pi. But then between that interval, we see that these are our two vertical asymptotes. Now, another way to approach this is to consider if tangent theta is the function we're looking at. If you go back to when we were just dealing with domain, we would say, when do we have issues in our domain? We have issues in our domain when we have division by 0, negatives under the square root, etc. But we don't see that with tangent theta from just looking at these words, tangent theta. But if you remember, tangent is equal to sine over cosine. And so now that I've created a rational function here, when I go to look at this and think, where are my domain issues going to be? They're going to be when this bottom is 0. So if you consider your trig circle, remember any dot or ordered pair on your trig circle is your cosine theta, comma sine theta. And so cosine is your x value as you're moving around. I want to figure out, when is that x value equal to 0? Well, it's going to be equal to 0 here and here. This is going to be at, if this goes from 0 to pi, this is at pi over 2, and this is at 3 pi over 2. And so where in our interval between 0 and 2 pi, that means looking at your unit circle, the entire circle, where do I have cosine to be 0? It would be up here at the top and up here down here at the bottom. And again, that's our two values that we already got. So for this problem, we can take two approaches. We can consider the tangent function, rewrite it as a rational function, and then consider when our bottom is equal to 0, go back to our unit circle. Or from our discussion of the graphs, we can realize that it's going to occur here at these vertical asymptotes, and then also pull those values. So kind of two different approaches to help with that one. 10 follows suit, so I'm going to do this in the same video. On number 10, it says on the interval from 0 to 2 pi, so we're just looking at the unit circle, again like the previous one, determine which angles are not in the domain of the given functions. And for this one, we're going to be looking at the secant function and the cosecant function. So you can see I already have some graphs set up for us. And so I'm going to take the graphical approach with both of them, but I'm also going to go back to my unit circle with both of them. So what angles are not in the domain? So basically, if we're looking for where that domain had issues, possibly division by 0. So first, let's look at the secant one and just look at the graph. If you notice on our secant graph, secant of theta is equal to 1 over cosine theta. You need to know those inverse functions there. Secant theta is equal to 1 over cosine. So again, you're looking where cosine of theta equals 0. You can see that cosine of theta equals 0 here and here. So you can see that when we created our secant graph, there is a vertical asymptote at that point, again, where that cosine of theta was 0. So what areas are not going to be in our domain? It's going to be pi over 2 and 3 pi over 2. And that's just kind of coincidental that it was the same as our tangent. And then so you can take the same approach with just the function, not considering the graph, and you go back to your unit circle and you say, okay, if secant theta is equal to 1 over cosine theta, similar conversation in number 9, where is the bottom equal to 0? But again, remember each of your ordered pairs on your trig circle is cosine theta comma sine theta. So where is it 0? Here, and we've already determined that this angle and this angle, again, is that pi over 2 or 3 pi over 2. So remember or commit to memory whichever way you can remember the easiest, either remembering from the graph in your vertical asymptotes or remembering from creating this fraction and figuring out where your denominator is 0. Now let's do the same thing. So we've got pi over 2 and 3 pi over 2 in the first one. Let's do the same thing for the second one on cosecant. So let's kind of shift over here to our cosecant graph. Now remember, when you're considering cosecant of theta, that is 1 over sine theta. So this answer is going to be a little bit differently. Graphically, it is still where you have these vertical asymptotes. So you have one here at pi and you have one here at 2 pi. So we are going to take out pi and 2 pi. But let's look at it from this approach of 1 over sine theta. If I look at it as 1 over sine theta, and again, consider your unit circle, sine theta, where does it equal 0? Well, in regards to my unit circle, my sine theta is the y value. So right here and right here is where I get sine theta to be 0. So this would be at either 0 or 2 pi, and if I circle this way, this would be at pi. So if we look at our domain restrictions up here, we are between 0 and 2 pi. Kind of covered it up there. We are between 0 and 2 pi, and we are including 0, but we are not including 2 pi. So the answers I want to enter for this one would be 0 because it has the square bracket. And we learned over here on our graph that that was at 0 or 2 pi. And then pi. And then I do not put 2 pi because although using my unit circle, I was here and here at 0 and then pi and then 2 pi. 2 pi is not within my interval because of that parentheses. So again, either consider your vertical asymptotes from your graphs or relate it back to sine and cosine in your unit circle. So I hope this helps with 9 and 10.